So in this example, we will find the centroid of a quarter of a circle, just the arc of a circle, using the polar coordinates. Okay. So remember that x bar is equal to the integral of x tilde dl divided by the integral of dl. Okay. So in the first example, we have seen how to change dl by dy or dx, but here we will change dl by d theta. Okay. So we will use polar coordinate. So the dl, what is the dl? So if we look a little bit closer to the dl is a little arc of circle, and this is the distance dl. Okay, and this distance is what? Is the little angle d theta inside time the radius. Okay, that's the formula for the circumference of a circle, but here that's the formula for the length of an arc of a circle. So dl is equal to r, the radius that is constant, times d theta, and d theta, that's the little angle that changes all the time. Now for the location of the centroid of this little element dl, so that's the centroid there. Okay, and x, let me put it in blue because we know it. That's your x tilde, and it's equal to what? So it's a circle, so it's equal to r cosine theta, and your y tilde, it's equal to r sine theta. That's the position of the little of the centroid of the little element dl. Okay, and for any theta, so if we are theta equals 0, oops, if theta equals 0, that will be there. Theta equal, I don't know, pi divided by 4, pi divided by 8, etc., etc. Theta change with that. R is always the same. Okay, so we found x tilde, y tilde, and dl in terms of theta. That's our variable. That's theta. That's not x, that's not y, that's theta. So let's find first the integral of dl. That's the integral of r d theta. So the question is, what are the limit of theta? The limit of theta, that's the angle. So the angle begins at 0. Theta equals 0. We go up to theta, it's equal to pi divided by 2. Okay, so the limit are from 0 to pi divided by 2, because that's the limit of theta. Okay. So the integral of dl is equal to r, because it's a constant, time the integral from 0 to pi divided by 2 d theta. And the integral of d theta is just theta. So we have the integral of dl that is equal to r time, so theta from 0 to pi divided by 2. So the integral of dl is equal to r time pi divided by 2. So the length, we proved that the length of an arc of a circle is the radius time the angle. That we already know that. Now for the x tilde, the integral of x tilde dl, it's equal to x tilde is equal to r cosine theta time r d theta, and that's in terms of theta, so that's from 0 to pi divided by 2. So the integral of x tilde dl is equal to r square, the integral of cosine theta d theta, 0 and pi divided by 2. And the integral of cosine theta is sine theta, so we have r time sine theta from 0 to pi divided by 2. Okay, and it's equal to r time the sine of pi divided by 2 minus the sine of 0. So it's equal to, so the sine of r of pi divided by 2 is 1, and the sine is 0, so it's equal to r times 1. So at the end, what do we have for x tilde? Let's make it smaller so I can keep writing. So x bar is equal to r divided by r times pi divided by 2. Oh, I forgot the square, sorry. R square. I knew it. So x bar is equal to 2 times r divided by pi. Here we go. That's the position of x bar. And we can use this now for any r, for a quarter of a circle only. Okay, not for a semicircle, just for a quarter of a circle. Let's do now, so we find y tilde. Now let's do y, the integral of y tilde dl. It's the integral from 0 to pi divided by 2 of r sine theta, the y tilde, this one, r sine theta, time dl, and dl is r d theta. So the integral of y tilde dl, it's equal to r square, integral of sine theta d theta from 0 to pi divided by 2. So the integral of y tilde dl, it's equal to r square, and the integral of sine theta is minus cosine theta, so minus cosine theta from 0 to pi divided by 2. So the integral of y tilde dl, it's equal to r square time minus cosine pi divided by 2 minus cosine 0. Cosine pi divided by 2 is 0, and this one is minus 1, so 1. So the integral of y tilde dl, it's equal to r square. So we get this the exact same answer. Y bar is equal to r square divided by r times pi divided by 2. So y bar is equal to 2 times r divided by pi. And that's true for any r, for any quarter of a circle in this quarter. Okay. And that makes sense that they have the same value, because, so let me clean that a little bit, because this is symmetrical about this axis there. And this axis is y equal x. Okay, so x bar should be equal to y bar. So be careful of your limits. Make sure to have everything in terms of theta. And when it's a circle, definitely theta polar coordinates are easier. Here we go. So that's it for this one. Bye-bye. And you see these two formula, no, that's it. These two formula, they will be given for the next section. You will have some usual shape, the location of the centroid of usual shape. That was just the proof that the location of the centroid of a quarter of a circle is always 2 times r divided by pi. Bye-bye.